Imagine traveling through space and suddenly reaching a place where time almost stops, a place with gravity so strong that nothing can escape it, not even light. Welcome to the world of black holes, cosmic mysteries that have baffled scientists for decades. Today, we reveal the strangest facts about these space monsters.
You're watching The Unbelievable World.
Before we understand how black holes distort time, we must first understand how these cosmic monsters are born. Deep in space, when a massive star reaches the end of its life, its nuclear fuel runs out. The star collapses under its own gravity, triggering a violent explosion known as a supernova. But sometimes, the explosion is not enough. The star's core continues collapsing, compressing matter to an unimaginable degree, until it forms a point of nearly infinite density. This is how a black hole is born.
An object that doesn't just swallow light, but bends the very laws of the universe. And one of the most dangerous laws it breaks is time. We like to believe that time is constant, that 1 second passes the same for everyone, everywhere. But the universe disagrees. Albert Einstein was the first to reveal this shocking truth when his theory showed that time is linked to gravity. The stronger the gravity, the slower time moves. And nowhere in the universe is gravity stronger than near a black hole. Imagine this. You are watching someone approach a black hole while you remain far away. From your perspective, years begin to pass. 1, 2, 10 years. But for that person, only minutes go by. To you, they appear to move in terrifying slow motion, as if time itself is freezing around them. But for them, everything feels completely normal. This phenomenon is known as gravitational time dilation, and it is not science fiction. We have already proven it. The satellites that power the GPS system orbit in weaker gravity than Earth, which means time moves slightly faster for them. If we didn't constantly correct this time difference, GPS locations would drift by kilometers every single day. Now imagine what happens near a black hole, where gravity is millions, even billions of times stronger. At a boundary called the event horizon, time, from our perspective, begins to slow down dramatically. Any object approaching the event horizon appears to move slower and slower until it seems completely frozen in place. But the truth is far more terrifying. The object has not stopped. It has entered a region where time no longer behaves the way we understand it. And this leads to one of the most disturbing questions in physics. If a human approached a black hole and spent only minutes or hours near it, could they return to Earth to find that hundreds or even thousands of years had already passed? Theoretically, yes. Black holes do not just consume matter. They reshape time itself.
If black holes emit no light, reflect no light, and cannot be seen directly by any telescope, then how did scientists discover them at all? The answer is simple and terrifying. We don't see black holes themselves. We see their effects. Just like you can't see the wind, but you can see trees bending under its force. A black hole reveals itself, not by what it shows, but by what it destroys around it.
When a star, gas cloud, or even a planet gets too close to a black hole, it doesn't fall straight in. Instead, it begins to spiral violently, forming what scientists call an accretion disk. A massive disk of superheated gas, spinning at incredible speeds, reaching temperatures of millions of degrees. Here lies the paradox. The black hole itself is completely dark, but its surroundings become some of the brightest objects in the entire universe.
This disk releases powerful X-rays that can be detected from billions of light years away. Through these signals, scientists began mapping invisible monsters hiding across the cosmos. But light is not the only clue. Black holes distort space itself in measurable ways. When light passes near a black hole, it does not travel in a straight line. It bends, it curves, it warps. This phenomenon is called gravitational lensing. Because of it, stars may appear duplicated, stretched, or shifted into impossible positions. We don't see the black hole. We see the universe breaking around it. Then, in 2015, something changed astronomy forever. For the first time in human history, scientists detected ripples in space-time itself, gravitational waves. Tiny vibrations in space and time, created by two black holes colliding billions of light years away. It wasn't light. It wasn't an image. It was a tremor, as if the universe itself whispered a secret we could finally hear. And then came the ultimate breakthrough. In 2019, humanity captured the first real image of a black hole. Not the black hole itself, but its shadow. A glowing ring of light surrounding absolute darkness. One image requiring telescopes across the entire Earth, decades of theory, and years of collaboration. This was more than a photograph. It was proof that Einstein was right all along. Black holes cannot be seen directly, but the universe around them cannot hide their presence. At the heart of almost every galaxy hides an invisible monster. Not a star, not a planet, but a supermassive black hole with a mass equal to millions, even billions of suns. These are not rare anomalies. They are the universe's hidden rule. No one has seen them directly, but we've seen their effects. Stars
racing at impossible speeds, clouds of gas pulled toward the galactic core, light compressed, distorted, screaming before vanishing. All signs point to one place, something enormous, invisible, yet undeniable.
At the center of the Milky Way lies a black hole called Sagittarius A. Its mass equals 4 million suns, and yet it remains relatively quiet. But don't be fooled. If it ever truly awakens, our galaxy will never look the same again.
Scientists are still searching for answers. Were they born from the collapse of massive stars? Or did they grow slowly, devouring everything that came too close over billions of years? Perhaps the truth is more terrifying than we imagine.
When a supermassive black hole feeds, it does not do so quietly. Jets of energy erupt, stretching across entire galaxies. These jets can ignite the birth of stars or end them forever. A black hole doesn't just destroy, it reshapes the universe. A question that still haunts scientists. Can a supermassive black hole swallow an entire galaxy? The short answer, no. But its influence is far deeper and more dangerous than you think. These invisible monsters are not enemies of the universe. They are its guardians of balance. Without them, galaxies might not exist as we know them. A black hole is not the end of everything. Sometimes it's what gives the universe its shape.
Thank you for watching The Unbelievable World. If you enjoyed this video, don't forget to subscribe and support the channel, because what's coming next is always more unbelievable.